Start. Hello everyone, today we are going to see the concept of double limit using polar coordinate. So now first we see the relation between polar coordinates and the Cartesian coordinate. So let point P with Cartesian coordinate x1 and let r theta be its polar coordinates. So suppose this is a point P with polar coordinate x1, and that's fine. If we draw this perpendicular on x-axis, say PQ, so this distance is nothing but y coordinate and OQ distance is x coordinate. Similarly, join the point O and P. So distance of the point P from the origin is its first polar coordinate, that is r, and second polar coordinate is nothing but the angle XOP. So this is equals to theta. So now from this in this right angle triangle we find first cos theta. Cos theta is equals to adjacent side upon hypotenuse. So cos theta equals to x upon r. It gives x equals to r cos theta. Similarly, find your sin theta. Opposite side upon hypotenuse, that is y upon r, which is same as y is equals to r sin theta. So now here we get two relations which gives the relations between Cartesian coordinates and the polar coordinates. If we squaring and adding these two equations, we get here x square plus y square equals to simply r square. Since r is positive, therefore r is equals to square root of obviously positive x square plus y square. Similarly, take the quotient x upon r, which is same as r cos theta upon r sin theta, that is cos theta, which is same as theta equals to tan inverse of y upon x. So these two relation gives value of r and theta in terms of x and y. So now just here, suppose I say that as xy tends to 0, 0. Here xy tends to 0, 0. So obviously r is equals to root of x square plus y square also tends to 0. Okay. See in the diagram. Suppose I say that xy tends to 0, 0 along this straight line. Then in this case r also tends to 0, 0 here. So remember, these are the basic concept for finding the double integral using polar coordinates. So let us take one example. Find the limit of 2xy upon x square plus y square as xy tends to 0, 0 using polar coordinate if exist. So now for that, first write relation between polar and Cartesian coordinate. X equals to r cos theta, y is equals to r sin theta. So we know that if you squaring and adding these two equations, we get simply x square plus y square equals to r square. So suppose the given limit is denoted by L. So L equals to limit of, write to as it is, value of x is r cos theta, value of y is r sin theta upon x square plus y square is nothing but r square, and as we know that xy tends to 0, 0, r is also tends to 0, and there is no change in r. So this is for in theta. So which is same as limit of r tends to 0. See here, this r square gets cancelled with this r square. So remaining is 2 sin theta into cos theta. We cancel here r square because here r tends to 0. So it is not exactly equals to 0. So which is same as 2 sin theta cos theta is as it is because it is independent of r. So this is same as sin 2 theta. And we know that the value of sin 2 theta is lies between -1 and +1. So limit is definitely depends on the value of theta, and that's why since it depends on the value of theta, we say that limit doesn't exist. Okay. Now consider another example. So now we consider a simplest change here. So simply I consider here 2l x cube y upon x square plus y square as xy tends to 0, 0. Find this limit if exists by using polar coordinate. Again see here. So we write here x equals to r cos theta, y is equals to r sin theta. So we get here x square plus y square is same as r square. So now put this value in given limit L. So it becomes 2 as it is. X cube is nothing but r cube cos cube theta into r sin theta divided by x square plus y square is r square. This is for any theta. So this is same as limit. Again here this r square gets cancelled with this r square, remaining is 2. Here power of r is r raised to 4, but r square gets cancelled, so only r square is remaining. So after simplification we get here 2 r square cos cube theta into sin theta. Okay. So this is same as. Now here we apply one theorem. The theorem says that limit of fx into gx as x tends to say a is equals to 0 if limit of one function, say fx, as x tends to a is 0 and another function gx is bounded function. So now here the limit of r square, so this L can be written as limit of r square, another function 2 cos cube theta into sin theta as r tends to 0. So this is our function f and this is our function g. So now here limit of r square as r tends to 0 is 0 and the another function is bounded function 2 cos cube theta into sin theta is bounded function. Why it is bounded? See, to show that it is bounded, we consider mod of this, mod of 2 sin cube theta in sin cos cube theta into sin cube theta, which is same as 2 as it is, mod of cos cube theta into sin mod of sin theta. We know that the maximum value of cos theta is 1, so it is 1 cube, and this is maximum value of sin theta is also 1. So mod of this quantity is less than equal to, that's why it is a bounded. So since this function is bounded function and limit of this function is 0, so that's why the total answer is equals to 0. Okay, so this is one of the powerful method to solve the double integration. So it is applicable in both cases where limit exists or limit doesn't exist. Thank you.